I wanted to cover factoring in 2 videos because I wanted to cover the essentials of factoring. The signs, procedure, all that stuff, because the repetition and the understanding of factoring is so, so important. But I also wanted to take time to cover some really, really nasty factoring problems. I spend more time on that in the book than I will in this video. I'm only going to cover the one in the video. So check out those examples. Now, these aren't the most common of problems, these terribly nasty ones, but they are somewhat common. You see them on about 50% of tests. You do see a lot of the tougher factoring, or what used to be called intermediate algebra factoring on the old school report, all over the place. You'll see really one of those on every test, but what makes it an intermediate algebra or a PHM factoring question is very arbitrary and somewhat thin line. So I've written a lot of problems in the book, in the problem set, where you can kind of see, oh, look at this little tiny extra step we have to do, or look at this twist on it. So check those out for more practice. Before we get into this problem at the bottom, I want to talk about difference of squares. This is the most forgotten concept in factoring, and it shows up on the ACT a fair amount. Whenever I have perfect square minus perfect square, that's factorable. There's no middle term. That means that the middle term cancels. How does it factor? Square root plus square root times square root minus square root. Let's go ahead and set these equal to 0. Giving me solutions that have the same absolute value that are opposite ends of the opposite sides of the number line. So you have a x plus 3 equals 0 factor, x minus 3 equals 0 factor, or x equals negative 3, x equals 3. Let's do another one or two. Perfect square minus perfect square. Why is there no middle term? Because the middle term cancels, because the square roots make it cancel. Square roots with opposite sides. Okay, let's try x squared minus 4. Perfect square minus perfect square. Square root plus square root minus square root. Again, solutions will be negative 2 and 2. Same solution in terms of absolute value, different signs. And finally, one more. This is a bit abstract, but you may come across it. I've seen it once or twice in old tests. Let's say we have x squared minus y squared. Well, we could cancel that doing, oops, I almost got into a rational expression there. We can factor that by doing x plus y, square root plus square root minus square root. Same thing. Remember the 2 variable stuff doesn't really matter in terms of factors. One other little thing I want to cover is factoring with powers greater than 2. So let's say I have something like this. X to the 4th plus 2x squared y squared plus y to the 4th equals 0. Boy, that looks intimidating. It's not, okay? As long as I have even powers on my ends, 4, 4, I can factor this. You'll notice that it has to factor pretty well because there's only 3 terms. Like, if this was like x squared in one, x squared in the other, but then it's like y to the 3rd and y to the 1st, you'd have 4 terms. So this factors evenly, and it even tells you here how you would factor those x's and y's, because those middle terms. So what do? We split that exponent in half, and you see it works here because of our middle term. X to the 4th becomes x squared, and x squared. End sign's positive, either plus, plus, minus, minus. Middle sign's positive, that means it's plus, plus. Same thing here. I know this 4th breaks into 2 and 2 because it tells me in that middle term. No numbers. Well, there's ones, but no coefficients other than 1 on these. So I'm done. I can multiply these together. Remember, when I have the same base, I add the exponents. So it would be x squared plus 2. By my middle terms, 2x squared y squared. That's it. Now, let's get to the meat and potatoes of this. The problem you see below is something I've seen several times on real actual ACTs. there's a really nice trick to it. You can also use this line of reasoning a lot in rational expressions. So check out the videos there, and you'll see that you're going to kind of use the same trick. The quadratic they give you is really, really nasty. First off, we have a coefficient that's not 1, right? Got a decently large middle term. Decently large end term, which always kind of makes it tougher because, you know, by and large, although not always so, of course, because you have big prime numbers or whatever. Bigger numbers have more factors, so there's more possible combinations. To add to that, negative end signs. So what does that mean? We've got mixed signs. We got a plus and a minus. Right? So that's really all we know right now. And it's going to be really hard and take a lot of guesswork to get much farther because we're not only dealing with factoring this 18 and dealing with a difference instead of just an addition. We also have to figure out how to do this 4. Is it 2, 2? Is it 4, 1? If it's 4, 1, where does the 4 go in relation to the numbers here? This one could take a long time to factor. Remember, though, the ACT is designed to be solved 60 seconds per question. So they say if x plus 6 is a factor. Okay. So I just filled out my plus factor. Just like that. That's half the problem done. Actually, way more than half the problem done in terms of the effort you need. Here's what I'll do. I'll kind of solve it backwards. And you'll see a lot of examples of this in the book, so really check those out. I'm going to solve this backwards, and here's how I'm going to do it. I'm going to say, well, it's kind of like FOIL, right? X times something is 4x squared. X times this. X times this first blank right here is 4x squared. That means this has got to be 4x. There's no other way around it. 6 plus times something over here is negative 18. 6 times something is negative 18. That's just got to be negative 3. That's it. That's all you have to do. Now, you can go back and FOIL this out, right? X times 4x is 4x squared. That's my first. Outer. X times negative 3, negative 3x. Inner. 6 times 4x is plus 24x. You can already see 24 minus 3. That's going to give me my right middle term. And then 6 times negative 3 is negative 18. It all goes. There's a great shortcut, back solve. And you'll see that again in rational expressions. You know, you'll have maybe a really complicated expression where you have like factors on top. You know, you have something like this, and then like an x plus 1, and then you have some complicated trinomial, and then x plus 6 on the bottom. So you would try this factor as a component of this quadratic, and this factor here. And I'll talk about that in that video. Check it out.